Welcome back to my YouTube channel, and in today's video we are going to be talking about the air standard diesel cycle. That is the air standard diesel cycle here. So now first of all, look at this PV diagram here. It is a little bit different from the air standard auto cycle because the air standard auto cycle has two constant volume processes, while in air standard diesel cycle there is a constant volume process, which is this year. We have a constant volume process over here, and we have a constant pressure process over here. So that is um that is the difference between the diesel cycle and the auto cycle. And if we look at the TS diagram, that is the temperature to entropy diagram, it is a little bit different from that of the auto cycle. So now the auto cycle is different from the diesel cycle in description, and in auto cycle what is being used is the spark plug. That is, the spark plug is what is used for ignition, and in the diesel cycle it's compression. There is more compression, and the compression is what is used for ignition. Now in a diesel cycle in motors and different vehicles are fuel efficient, and they can travel long distances, and they are more reliable. They have more efficiency than they have more efficiency than the auto cycle. So we let's look at calculations under let's analyze this diesel cycle over here. First of all, the process 1 to 2 over here is the isentropic compression. That is the adiabatic and reversible compression. That is, and we know whenever we have isentropic, we have, the formula that we use, the PV raised to power gamma is equals to constant, and the T1 V1 raised to power gamma minus 1 is equals to the constant C, stuff like that. So that is the isentropic compression. And here is where we are going to be having our compression ratio, and we need to note that the compression ratio in diesel cycles are usually way larger than the compression ratio in auto cycles. So now from the number 2 to 3 here is where our heat is being added, and the 2 to 3 here is known as the isobaric heat addition. Isobaric means that we have constant pressure, so we have constant pressure, and there is heat addition. So that is that, and then from 3 to 4 is our isentropic expansion. And so we need to know that between that 2 to 3 and our 3 to 4, there is something called our compression ratio and then our expansion ratio. So our compression ratio and our expansion ratio, and um our cutoff ratio and our expansion ratio. Our compression ratio is V1 over V2. Our expansion ratio is V3 over our cutoff ratio is V3 over V2. Our expansion ratio is V4 over V3. That particular sense. Okay. So that is it for our expansion ratio and our compression and our cutoff ratio. So we are going to be getting into that very soon. So now we know our 3 to 4 is our isentropic expansion, and then our 4 to 1 is our isochoric heat rejection. That is where we have our Q out and that. So now let us look at the values that I just talked about here, which are the compression ratio and this ratio. So we know that our compression ratio this is equals to V1 over V2 as usual, and most of the time is what is going to be given, V1 over V2. So, and I also mentioned that from 2 to 3 here there's something called the cutoff ratio. So in our cutoff ratio, I'm going to be having this as our cutoff ratio, this it here, is equals to our V3 over V2. That is V3, our V3 over V2. V3 over V2. So we have that as our cutoff ratio, and also we need to take note of our expansion ratio here, which is this. Our expansion ratio is equals to our V4 over V3. So now these are the three different ratios that we are having in our diesel cycle. So that if we are to calculate if we are to calculate the thermal efficiency, we know how we did the thermal efficiency. That we know that we cannot just have something like 1 over 1 minus 1 over the compression ratio raised to power gamma minus 1 in this particular scenario. This is going to be a very much more longer equation that is going to be used in this particular case. And then we need to take note that as the cutoff ratio increases, there is more power available, which means that there is a longer period of retardation in an actual engine, a longer period of fuel injection. That is when you add diesel fuel or fuel into the engine. So now let's talk about our compression ratio and how the formula for compression ratio is being gotten. Now, before I start, I'm going to write out the compression ratio here. Our compression ratio here um is equals to 1 minus 1 minus, now this is where this thing happens. We have 1 over our compression ratio first raised to power gamma minus 1 raised to power gamma minus 1. Then we have multiplied by our cutoff ratio raised to power gamma, our cutoff ratio raised to power gamma, then the minus 1 is here, divided by our normal constant gamma here into brackets cutoff ratio minus 1. So now this is the formula for thermal efficiency that is in this particular form, and it is still derived from the same formula in which we used for our normal efficiency when deriving it for the Otto cycle. So now deriving it for the diesel cycle, we know normally that our this is equals to W net over our Q in. W net over our Q in, and yeah, this is the normal formula, and we know that our W net is equals to Q in minus Q out. So we have Q in, which is our Q1, minus Q out. Q in minus Q out. So, and then if we divide this, we are eventually going to get 1 minus Q out over Q in. Q out over Q in. 1 minus Q out over Q in. This is what you are eventually going to get. And now from this point is where there might be a problem. So now from the remaining parts, Q out and Q in, we know how to get our Q in and then our Q out, but let's look at it. So now we have heat addition here, which is our isobaric heat addition from 3 to 2. So now we can decide that our formula for Q in will be equals to M. Now the constant here is not going to be Cp, because in that Otto cycle we were having an isochoric process, but now this is going to be an isobaric process. So it is going to be an isobaric process. This is going to be equals to our 1 minus, what is our Q out? Our Q out is equals to M times our C V, yeah, because our Q out is from 4 to 1. This is our Q out. Our Q out is from 4 to 1 over here. So we can just, that one is constant volume, and that one is from 4 to 1. We have T4 minus T1. Then we do our brackets, then divided by our Q in. Now for our Q in, when it is added, it is an isobaric equation too. Therefore, we're not going to be using CV, we are going to be using the constant Cp. We are going to be having our mass M, C P, then it is going to be T3 minus T2. T3 minus T2. So that is what is going to be here. And so if we advance from here, we already know that our m cancels our m over here. So what is left is this. Now, first of all, one thing that I might not have mentioned throughout the entire series of this is the fact that one thing that I might not have mentioned is that um gamma this gamma, which is this constant, is equals to Cp over Cv. That is, this constant here is equals to Cp over Cv. And we know that that gamma is equals to 0.4 that we have been using in our 1.4, which we have been using in our equations. So therefore, if Cp over Cv is equals to gamma, therefore Cv over Cp can give us 1 over gamma. So therefore, we are going to write this as t is equals to 1 minus, we have 1 over gamma, which is our Cv over Cp, 1 over gamma. We have our brackets of T4 minus T1 over T3 minus T2. We have T4 minus T1 over T3 minus T2. Here. So now this is going to be what we are going to get. So now, first of all, it might look hopeless from this particular point, that how do we get to relate these values over here to their respective value of t to the respective value of compression ratio and that. So now, first of all, the first thing that we need to do here is that we need to factor out the value of T1 from this upper bound here and the value of T2 from this lower place here. So if we factor them out, we are going to be having something like this. We have our 1 minus 1 over gamma here multiplied by, which just a dot here, multiplied by. Now if we factor out T1 from the upper one and we factor out T2 from the lower one, so we can open our bracket. So we are factoring out T1 from the upper one, and if we factor out T1 from this particular place, this is going to become here we have T4 over T1, we have minus 1, and the lower one in which we factor out T2 is going to become T3 over T2, then we have our minus 1. So that is it for that. So now, since we have factored this out, so now we need to go back to our isentropic relationships, whereby we know that while we're dealing with our isentropic relationship here, if we're dealing with our isentropic relationship, we know that T2 over T1 would be equals to our compression ratio raised to power gamma minus 1. And I think I've solved questions under this and how we got to this particular point, which is our T1 V1 raised power gamma minus 1 is equals to T2 V2 raised power gamma minus 1. But our V1 over V2 is our compression ratio, which is how we got here. So we know that for our T2 over T1, therefore we know our T1 over T2 would be the inverse of whatever that is here. And also, if we continue if we continue from this place, we can look at our diagram here, whereby we are having our Q in our constant pressure between 1 and 2, between 2 and 3, our constant pressure process, we can determine that our T3 is equals to T2 constant pressure process of that. And what we are just trying to do here is that we are trying to derive a value for what we have here as our T4 over our T1 over here. That is our T4 over T1. We're trying to derive a value for that. We are trying to derive a value for our T4 over T1 and a value for our T3 over T2. But here we already know that our T2 over T1 is equals to whatever that we have here. So now we come here and we also say that since we know there is a constant pressure process between the part 2 and 3, therefore the value for the volume will not be constant. So therefore we can use the formula of v2 over t2 is equals to v3 over t3. So let's use that formula. I'm going to use v2 over t2 v2 over t2 is equals to v3 over t3 over t3. So now that is the formula that we are going to be using here. And now if we try to make like t3 over t2, let's look at what we were dealing with over here, which is our t3 over t2. We try to make our t3 over t2 the subject of the formula. So we are going to be having t, we multiply both sides, we have t3 over t2, t3 over t2, our t3 over t2 would be equals to our t3 over t2 would be equals to our v3 over v2 in the same sense. v3 over v2. And now what is the value for our v3 over v2? Our v3 over v2 is known as our compression ratio. So this here is our cutoff ratio, there is known as our cutoff ratio. So we can say that our t3 over t2 from these parts is our cutoff ratio here. And now what about our t4 and our t1? So we might not be able to get the value for t4 over t1 directly, so we might just need to cut off, we might need to do some manipulations over here. So first of all, we deal with t4 and t3. So now let's talk about t4 and t3. So now so we know if we are to do the isentropic relationship between this between the part of this graph 3 and 4 here, which is this yellow line in which I draw here, this part 3 and 4. If I are to draw the relationship between the values of v and t there, we are going to be having our t4 over t4 over t3 our t4 over our t3 our t4 over the value of t3 would be equals to v3 over v4 v3 over v3 over v4 all to the power of gamma minus 1. So we have this all to the power of gamma minus 1. So, and we all should know how we got this formula from our formula of V3 T3 T3 V3 raised power gamma minus 1 is equals to T4 V4 raised power gamma minus 1. So now our V4 over V3 is actually nothing but our expansion, the opposite of our expansion ratio, but we cannot leave it here because we want to put this in form of our compression ratio and our cutoff ratio. So if we multiply this by V2 over V2, so we can just say this is equal to, into brackets, we open a bracket, we multiply this by V2, we have something like V3 over V2, that is inside the bracket here, and we have our V4 here. We are going to be having multiplied by V2, which is up here, over V4, or V2 over V4. Yeah, so now this is the manipulation that we are going to be doing in order to get our value for this year. So now we know that if we look back at our diagram here, we know that our V4 is the same thing as our value for V1 because of the isochoric relationship that is happening at the ending part over there. So we can say that this year, this value for V4 is the same thing as V1. So we just change it to V1. And now our V3 over V2 is our cutoff ratio. Our V2 over V1 is the opposite of our compression ratio. Is the opposite of our compression ratio. So therefore, we can just pick this as, this is equals to, open brackets, of our cutoff ratio divided by our compression ratio. Cutoff ratio divided by our compression ratio, all raised to power gamma minus 1. All raised to power gamma minus 1. So that is what we are going to get for that. So we can just make T4 the subject of the formula into here. We are going to be having the value for T4. T4 is equals to T3 into brackets of our cutoff ratio over our compression ratio, all raised to power gamma minus 1. So now this is the value for T4, and now we also have to manipulate for the value of T1. But now from this part here, we already know that our T2 is equals to our value for T1. Right? We know from this part here that our T4 is equals to T1, T2 over T1 is equals to the compression ratio raised to power gamma minus 1. So we can just make T1 the subject of the formula here. We know that our T1, yeah, our T1 is equals to T2 over the uh, over the compression ratio raised to power gamma minus 1, over the compression ratio raised to power gamma minus 1. That is compression ratio this raised to power gamma minus 1. So that is what T1 is going to be. So now what is our aim? Our actual aim is to get for this value of T4 over T1 that we have there. So since that is our aim, we are just going to move on and do our value T4 divided by t1. We're going to get our value for t4 divided by t1. We are having it as uh, so yeah, so we are having t4 divided by t4 divided by t1 over t1 would be equal to our value. What is our value for our t4? Our value for t4 is t3 into brackets compression ratio over volume ratio here is power gamma minus 1. So that is our, we know that as our, we have our t3, we have t3 into brackets compression ratio over cutoff ratio over compression ratio, all raised to power gamma minus 1. Yeah, so divided by that is t4 over t1. What is our value for t1? This is t2 over the compression ratio raised to power gamma minus 1. That is, we have that as our t t2 divided by the compression ratio raised to power gamma minus 1. Gamma minus 1. Gamma minus 1. So that is what is happening there. So now that is it for that, and we are just going to do a little bit of cancelling here. So if we simplify all of this we are going to be having, this here would cancel what is under here, and we also know that our t3 over t2 is also equals to our compression ratio, which is our cutoff ratio, which is gamma of c. So we just write our if we simplify all of this is going to give us, the value of compression ratio, which is t3 over t2, that is t3 over t2, which is here. T3 over t2 is equal to v3 over v2, which is our compression ratio, into bracket. After we cancel out the compression ratio, what we are left with is our cutoff ratio here, gamma raised to power gamma minus 1. Gamma minus 1. So now that is what is left here after we are done with t4 over t1. So therefore, if using the law of indices, this is going to be something that is going to give us our cutoff ratio raised to power gamma minus 1 then plus 1. And we know here that our minus 1 here, our minus 1 here is going to give us, our minus 1 here is going to cancel out with our plus 1. So this is going to be equals to the cutoff ratio raised to power gamma. So this is equals to be our cutoff ratio raised to our gamma. So now we have gotten our value for t4 over t1 and t3 over t2. We have also gotten our value for t1 over t2. Let me highlight them over here. Our value for t1 over t2 is what we got here, and we have also gotten our value for t4 over t1. This is our value for t4 over t1 over here, and also our value for t3 over t2. Our value for t3 over t2 is what we got over here. So those are the three values in which we have needed. So we just impute those values into this, we just impute those values into this formula back here, and we write it back as, we write this back here as no, this is equals to 1 minus 1 over, we have originally had our 1 over gamma here. We have 1 over gamma. Then we also have our T3, our T1 over T2, which is the inverse of T1 over T2 over T1, which will give us our 1 over the compression ratio raised to power gamma minus 1. So we have into brackets 1 over the compression ratio, 1 over the compression ratio, close brackets, into gamma minus 1, gamma minus 1. And then also for our value of T4 over T1 minus 1 and our T3 over T2 minus 1, we got our value for T4 over T1 to be equals to cutoff ratio raised power gamma, and our value for T3 over T2 to be just our cutoff ratio. So therefore we are going to be having multiplied by our cutoff ratio raised to power gamma, our cutoff ratio raised to power gamma, cutoff ratio raised to power gamma, raised to power gamma. Then we have minus 1 divided by whatever that we have here to be, this other one is just our normal cutoff ratio, our normal cutoff ratio. Then we have minus 1. So therefore if we simplify this, we are going to see that we got our same value as what I initially wrote here as this formula over here, which is 1 over gamma, the compression ratio is per gamma minus 1 multiplied by our cutoff ratio is per gamma minus 1 over gamma into bracket cutoff ratio minus 1. So that is how the formula is gotten to. I can just simplify this. If I simplify this, we are going to be having here 1 minus, we have 1 over our compression ratio here, our compression ratio, which is V raised power gamma minus 1, gamma minus 1. For that, then you multiply it by gamma cutoff ratio raised to power, cutoff ratio raised to power gamma, cutoff ratio raised to power gamma. Then we have minus 1. Then we have this divided by, our normal cutoff ratio here into brackets, our normal gamma into brackets cutoff ratio. Then we have minus 1, close the bracket. And so that is how the formula for our efficiency is gotten from scratch. Thank you very much for watching. Don't forget to subscribe, like, comment and share. Thank you very much.